Okay, so it says write the converse, inverse, and contrapositive of each statement. Okay, if I'm in Chicago, then I'm in Illinois. So let's write down the converse, inverse, and contrapositive. So we know that if P then Q, that's a conditional, right? So the converse is when you change the place of P and Q. So you have if Q then P. And inverse, you negate P and Q. So you have if not P, then not Q, right? And contrapositive, you negate P and Q and also you change the place of P and Q, right? So contrapositive is if not Q, then not P. We said that conditional and contrapositive, they are equivalent, okay? So if I'm in Chicago, P represents I am in Chicago, and Q represents I'm in Illinois. I'm in Illinois. Okay, so we have P and we have Q. Okay, so the converse, you change that, right? You change the place of P and Q. So converse is if I'm in Illinois, then I'm in Chicago. And inverse is if I'm not in Chicago, then I'm not in Illinois. And contrapositive says that if I'm not in Illinois, then I'm not in Chicago, right? Here we go. Don't forget to write in words. Here we go. Here's the answer. Okay, so here it says translate each argument into symbols, then find out whether or not the argument is valid or invalid. Okay, if all people obey the law, then no jails are needed. Some people do not obey the law, therefore, some jails are needed. Okay, so what I'm gonna do, I'm gonna follow 4 steps. Okay, so first of all, I choose P and Q. Okay, so P represents all people obey the law. And Q represents, okay, some jails are needed. I don't want to choose negated, okay? Some jails are needed. Some jails are needed. Guys, if the question doesn't tell you that P and Q should not be negated, so it's up to you how you choose P and Q. So here it doesn't say, so you can choose Q as no jails are needed, okay? So up to you. You're gonna get the same answer as mine. So PQ, then I'm gonna change the whole argument, step 2, into symbols. So look at the first line. So here's line 1, line 2, premise 1 and premise 2. First line, if all people obey the law, if P, then no jails are needed. Some jails are needed, Q, no jails are needed, not Q. Look at the second line. Some people do not obey the law. So it's not P. All people obey the law is P. Some people do not obey the law is not P. Therefore, so we have the line. Therefore, that's the conclusion sign. Some jails are needed. Some jails are needed. Q. Okay. So whatever you have above the line are your premises. Below the line, that's your conclusion. Now, step 3, we make a truth table, right? And then we make sense of the truth table. Okay. Well, I make the truth table here. So we have 2 ways to make sense of the truth table. Okay, so I'm going to explain both here. So I'm going to make a truth table. So we have PQ, 2 statements, 4 possibilities. For half of them, P is true. For half of them, P is false. When P is true, Q is either true or false. And when P is false, Q is either true or false. Here we go. Well, first premise is if P then not Q. Okay, so I need not Q. So I'm going to make not Q first. That's the opposite of Q. So whatever you have for Q, make the opposite and write it for not Q. Okay. So now that I have not Q, I make if P then not Q. Okay. So your start is P antecedent. Okay, first column. Your consequent is not Q. Okay, third column. So look at that. First column and third column. Your start is true, consequent is false, so conditional is false. Your start is true, consequent is true, you get a true value. Your start is false, look at the third and fourth column. Your start is false, you don't even need to look at your consequent, right? Your conditional statement is considered to be true. So you have premise 1, so I labeled that P1, premise 1, okay? Now premise 2 is not P. Well, that's easy, not P. Okay, so I label that premise 2, P2. Okay, not P is the opposite of P. P you have true, true, false, false. So I make that false, false, true, true. Here we go. Now conclusion is Q. Guys, you have the conclusion. You can just label that. That's your second column, okay? Or if you want all the premises and conclusions to be together, you can just rewrite your Q, okay? I just copy the Q here. True, false, okay? And here you go, conclusion, okay? So we have two ways to make sense of the table, okay? Well, one way is that you make premise 1 and premise 2, and then if premise 1 and premise 2, then conclusion, and see whether or not you have tautology. Another way is that you can just stop here, only focus on premises and conclusion, this part of the table, and go row by row. If you find any row for which all premises are true and conclusion is false, then you have an invalid argument. If you cannot find such a row, then you have a valid argument. So I go row by row. All premises true. First row, all premises are false. No. Second row, 1 is false. Okay, third row, all premises are true. Look at the conclusion. No, it's true. I'm not looking for this row. Keep going. Okay, look at the last one, last row. All premises are true. Conclusion is false. Okay, I found it. What does it mean? I have an invalid argument. So I found a row. I was able to find a row with true premises and false conclusion. Therefore, argument is invalid. Therefore, the argument is invalid. I was able to find the row that I was looking for. Well, another way is that, okay, I'm gonna write it down here, okay? Well, I make the truth table. I'm gonna make it here. So we have P, we have Q. We have two statements for possibilities. For half of them, P is true. For half of them, P is false. When P is true, Q is either true or false. When P is false, Q is either true or false. I want to make the premises and conclusion. So premise 1 is if P then not Q. Okay, so I need not Q. Not Q is the opposite of Q. So true becomes false, false becomes true, true becomes false, false becomes true. Just like before. Now I make premise 1, okay? If P, then not Q. Okay? Your start is first column, your consequent is third column. So, look at P. Your start is true, your consequent is false. So, the conditional is false. Look at the second row. Your start, your antecedent is true, your consequent is true, so the conditional is true. Well, look at the third and fourth column. Your star, P, is false. You don't even need to look at your consequent, so conditional statement is true. Okay, so here's your first premise, okay? Premise 1. premise 1. Premise 2 is not P, right? So here it is, premise 2. That's really easy. That's the opposite of P. So P is true, true, false, false. So not P is false, false, true, true. Okay. Now, guys, what we do, we make premise 1 and premise 2. So premise 1 is if P, then not Q. Okay, and premise 2 is not P. Okay, we make this one. So it's premise 1 and premise 2. Okay, P1 and P2 I wrote. Okay, premise 1 and premise 2, we want to use conjunction between them for conjunction for and. Both must be true to get a true value. Look at the first row. Both are false, you get false. The second one is false, you get false. Okay, third one, both are true, you get true. Last one, you have true and true, right? You get true. Okay, now, if premise 1 and premise 2, then conclusion. Okay, now we have if P, then not Q, this one, and not P. If premise 1 and premise 2, then conclusion. Your conclusion is Q. Okay, so P1 and P2, premise 1 and premise 2. If premise 1 and premise 2, then conclusion. We make that. Okay, so premise 1 and premise 2, we have it. That's your antecedent, and Q is your consequent. Okay, so your antecedent is false. You don't even need to look at your consequent. Conditional is true. Look at the second row. Your start, antecedent is false, so conditional is true. Look at the third one. Your start is true, your consequent is true, you get true. But look at the last row. Your start is true, your consequent is false, you get false. Guys, do you have tautology? No, we have a false value. So there is no tautology. So the argument is invalid. As you see, we have exactly the same answer as before. The argument is not valid, right? So here we go. Here is the answer if you want, P, Q, and I wrote down the premises and conclusion. I draw a truth table. So here I have presented the first, the method that you just go row by row, and you have an invalid argument, and here we go. So here it says use De Morgan's laws to write a statement which is equivalent to the given statement. Okay, it's not the case that my high school encouraged creativity and diversity. Okay, well, I still do statements. One is, my high school encouraged creativity and the other one call that Q. My high school encouraged diversity. Okay, it says it's not true that, okay, it's at the beginning, so the whole thing is negated. So it's not true that my high school encouraged creativity, P, and diversity, Q. Okay, so I use De Morgan's law. Okay, negation acts on P, becomes not P. Negation acts on and, changes that to or. De Morgan's law. Negation acts on Q, changes that to not Q. So we have not P or not Q. So the answer is my high school is not P, right? My high school did not encourage creativity or did not encourage diversity. Here we go. So, get that question. Negation of not P or not Q. Okay, the negation of not P, and Q. Okay, the negation acts on not P. Guys, negation of not P is P. Negation acts on and, changes that to or, De Morgan's law, and negation acts on Q, changes that to not Q. So the answer is P or not Q. There we go. Okay, that's the answer. So that's what we covered. That's right. Okay. Write a statement that is equivalent to, if there is a Janet quiz on Thursday, I do not go out and I study. Well, we have a hint that if P then Q conditional is equivalent to, it's contrapositive. If not Q, then not P. So I give you 1 minute, around 1 minute to answer this question, okay? Go ahead. Okay, so I'm gonna choose PQR. There is a Janet quiz on Thursday, so I call that P. Okay, so P represents there is a Janet quiz on Thursday. And Q, I go out. And I see another simple statement, I study. I represent that with R. R represents I study. Okay. So I change the statement into symbols. If there is a Janet quiz on Thursday, if P, then, and we have comma, whatever comes after comma, they're grouped together, okay? It's a separate group. I do not go out. I go out is Q. I do not go out is not Q. And I study R. Here we go. I know that if I have if P then Q, it's equivalent to if not Q, then not P. Okay, so I know that this statement is equivalent to, okay, I change the place of antecedent and consequent and I negate them. So if we have if P then Q, Okay, it's equivalent to if not Q, then not P. So I changed the place of antecedent and consequent, and I negated them. Okay, so here's the equivalent that we have. And the question asks you to write down the equivalent statement. Okay, so, well, I'm gonna use De Morgan's law here. Okay, so I have if not, negation of if not Q and R, then not P. So the negation acts on not Q. Negation of not Q is Q. The negation acts on and, changes that to or, De Morgan's law, and negation acts on R, changes that to not R. So we have if Q or not R, then not P. Now I change them into statements. If Q or not R, okay, so if I go out or not R, I do not study, then not P. There is not a Jeanette quiz on Thursday. Here we go. I wrote down the equivalent statement, right? Okay. So I pick P, Q, R. I changed the whole statement into symbols. So I wrote down the contrapositive, right? I used De Morgan's law, and then I changed the symbols into statements. Okay, I'm gonna end here. Okay, thank you.